Okay, this lesson in Chapter 10 is all about the area of different geometrical figures. And this particular lesson, both 10.1 and 10.2 have been combined. And all we're going to do in this video is just basically go over all of the different formulas for finding the area of all the different figures. Then what you will do is spend some time actually practicing with those. But this lesson's just about getting those formulas written down. So we're going to start with the area of a rectangle, and many of you already know what a rectangle looks like. You also are very familiar with all of the characteristics of a rectangle, but let's go over them. So in a rectangle, opposite sides are equal to each other. So the top and the bottom are both equal in length, and the left side and the right side are also equal in length. So that's a characteristic of a rectangle. Please note that all four sides are not equal to each other. It's just the opposite sides are equal. We also know that all the four corners in a rectangle are right angles. So very important to know some characteristics. Opposite sides are congruent, and all angles are 90 degrees. So all four angles are right angles. So congruent opposite sides and right angles. So the formula for that to find the area of a rectangle is area equals base times height. And typically in geometry we use base times height instead of length times width. And it doesn't really matter essentially. We're doing the same thing. So we're going to take the area of the bottom, the base, or the length of the base, sorry. We're going to multiply that by the length of the height. Okay? And that gives us the area. Area being the space within the boxed-in area. So how much space does that boxed-in area take up? The area of a parallelogram. So the first thing, again, we need to do is figure out what does a parallelogram look like. And so it's really, I always tell students, it looks like a rectangle that's been squished over. So it's a rectangle, essentially. It has the top and the bottom that have exactly the same length, and its left and right sides are the same length, similar to a rectangle. So again, we're going to have congruent sides. Sorry, I should say congruent opposite sides. That would be more appropriate. So congruent opposite sides. All right. Notice though that the angles are not all equal to 90 degrees. What we do know about the angles though is that opposite angles are congruent. Opposite angles are congruent. That means that this angle up here equals this one down here. They're opposite from each other. And this angle up here equals this angle down here. They're opposite from each other. Something else you might want to know about a parallelogram is that the sides are, it's called a parallelogram because the sides are parallel to each other. And so if you remember, parallel lines are two lines, and usually we show that they're parallel by putting this little triangular shape on them. So I know that those two sides are parallel. And when you put a line through it, we call that a transversal. Then we know that these two angles in here add up to 180 degrees. So what I'm telling you is that if I call this angle A and I call this angle B, then A plus B equals 180. Always. Okay? A plus B equals 180. And so, in other words, two in a row. So, for example, if I said, label this C and D, I could say the two bottom ones, B plus C equals 180. Or the two on the side, D plus C equals 180. Or I could also add A plus D equals 180. So, all of the angles beside each other add up to 180 degrees. That's also some characteristics that are very important for you to know. And so, how do you find the area of a parallelogram? It's the same exact formula, area equals base times height, as the rectangle, here's the problem. The height of a parallelogram or of any figure is the shortest distance between its top and its bottom. And so if we look back to the rectangle, the shortest distance from its top to its bottom is in fact the side of the figure. But in the parallelogram, the shortest distance from the top to the bottom is that segment I just drew in, the dotted segment. It's called an altitude, okay? So this green segment is called altitude, and that means it is the height of the figure. So, as you could imagine, in some of the figures, when we get ready to figure out its area, we are not going to be given that segment, and we're going to have to use what we know about 30, 60, 90 triangles and what we know about 45, 45, 90 triangles to find the length of that height in order to plug it into our formula and get the area of a parallelogram. All right, so area of a rectangle, area of a parallelogram, both base times height. Let's fill in the blank. The term base is used to represent both a segment and its length. A segment and its length, the base. A base of a parallelogram is any of its sides. So that means that the parallelogram can be standing on end, or the rectangle. So in other words, I could have it standing this way, and this would be the base, and this would be the height. So what they're saying in this paragraph is the base is used to represent a segment and its length. So the bottom segment and its length, or the bottom segment and its length. It doesn't really matter which one it's sitting on. Whatever it's sitting on or standing on is its base. The corresponding altitude, so let's put in altitude. The corresponding altitude is a segment perpendicular, so you'll notice when I drew it in up here, my altitude, I put in a right angle because it is the shortest distance. It has to be perpendicular. It has to be a right angle always. So it says that the corresponding altitude is a segment perpendicular to the line containing that base, drawn from the side opposite the base. And I'm just going to redraw that for you. So let's say my figure looks like this, and I'm trying to get this height. It's going to be the shortest distance from the top to the bottom, and it's going to form a right angle. The height is the length of that altitude. Okay? So these are just examples of the fact that they can be sitting on whatever side they want to be sitting on. Height and altitude are the same thing, okay? So in this picture, the first one on the left, I'm going to color the base blue. Okay? And I'm going to color the height red. So remember, the height forms a right angle with the bottom, and it is the shortest distance from the top to the bottom. So this is the height. Okay? Base times height. But I could also flip the figure, and they do this a lot in the book and on the practice pages when you're working on these to try to trick you. They call this the, oh, I'm sorry, wrong color. They call this the base, even though it's not sitting on its base. Remember, it said usually it's sitting on its base, but it doesn't have to. It represents a segment and its length. It doesn't have to be standing or sitting on its base. It usually is, but not always. And if that's the case, then how do you measure the height? Okay? How do we measure the height? Okay, so here's what we would do. We would extend the base, and then we would draw the right angle perpendicular to the top. So you have to turn your paper and look at it from the perspective of the base being on the bottom, right? And you could also do that in here. Usually when it's a parallelogram, the height is within the figure, inside the figure, like it was up here in the parallelogram. It's inside the figure, but it can also be outside the figure, like over here. So we could also have the height on the outside of the figure. So this is the height on the inside, and this is the height on the outside. And you can see that it forms a rectangle when we're done. The bottom is the same length as this, and this height will be the same length as this height. So it doesn't necessarily always have to sit on its base. We just wanted to make sure that you are thinking about it from different perspectives. Okay? So let's try some examples. You clear the screen, scroll the page up. So the first thing we want to do is these examples. And let me draw in some information for you. So on this parallelogram, I want you to know that this segment is 5 inches and that this is 4.5 inches. That's hard to write so small. And that this segment, forming the right angle, is 4 inches. All right. So if we had to find the area of that, first I need to know what kind of shape it is. So it's a parallelogram because the it's a parallelogram because the angles are not right angles. So it's a rectangle that's sort of been squished over. So the opposite angles are equal, but they're not congruent. So that's a parallelogram. Area equals base times height, and I know my base to be 5. The question is, which one of those is the height? Is it the 4.5, which represents this segment, or is it 4 inches, which represents that segment? And so I hope you say 4, because the height is always the shortest distance between the top and the bottom and forms the right angle. So there's your height. And so all we need to do right now is multiply. Now, what is your label going to be? If you have 5 inches times 4 inches, 5 times 4 is 20. Inch times inch is going to be inch squared. So area is always in square inches, or square feet, or square centimeters, or square whatever unit you're using. So just be sure that you are labeling those correctly. Let's look at example 2. I'm going to tell you that this segment is 2 centimeters and that this one is 4.6 centimeters, and that we have, let me move this out of the way for a moment, we have this segment drawn in for us that has a length of 3.5 centimeters. And now we have to solve the problem. Again, decide what shape you have. This is, again, a parallelogram. Okay, area equals base times height. The base is 2 centimeters. Again, what's your choice for height? Is it this segment, which is a side, or is it the shortest distance between the top and the bottom? So I hope you said the shortest distance between the top and the bottom, 3.5 centimeters. When we multiply 2 times 3.5, we get 7. So the area is 7. And again, centimeters times centimeters is centimeters squared. So 7 centimeters. All right? Number 3 is a bit of a trick question in that it's giving you some information and not all information. So they're making it a little bit tricky. Okay, so let me label it for you. We have A. Oh, geez, my marker's stuck. Try that again. We have A. We have B, C, D. This corner is F. And then we have to draw in this altitude. And we're going to call this segment E. And I'm going to tell you that the bottom is 10 inches. So that segment AB is 10 inches long. The side AD is 13 inches. This height is 12 inches. That's a 12. see if I can fix that for you. So 12 inches, there we go, looks better. And you have to find this segment. We're going to call it X. So I want to know what that height is over there on the outside. And so here's what is suggested for you to do. It's sort of a work backwards kind of situation. I want to know what the height is here, which means I also want to know what the height is. So if I want to know what this height is, I also want to know what this height is on the inside, and I have no information about that. However, if I find the area of that entire parallelogram, so maybe I take the area of this whole thing, which I can find because I have base and I have its height, then I can work backward using a different perspective. So here's what I mean. Number one, you're going to find the area of the parallelogram that's given to you. So A, B, C, D has an area, base times height. Okay. The base of ABCD is 10, and the height of ABCD is 12. So when I multiply that together, I get an area of 120 inches squared. So I know the area of that figure. So I'm going to work backward now, and I'm going to try to find the area of CF. But instead of using AB as the base, I'm going to turn my paper, and I'm going to say, here's my base. Sorry, not all of that. Not that section, just this part. The base, which I know to be 13, times the height, which is going to be X. And I know the area of that figure, because I just found it, is 120. So I'm going to use some substitution here. So step 2 is going to look like this. The area equals the base times the height. And I know the area is 120. And I know the base is 13, and now I just have to solve for the height, which of course is X, so let's put it in there as X, because I don't know what it is, that's what I'm solving for. So now this becomes a very simple algebra question. 13 times X, what am I going to multiply by, or divide by? 13, and so I do 120 divided by 13, and I get 9.2 for X. So the height is 9.2 inches. Okay, so it's a little bit of a longer problem.